So far we've just been looking at Server Studio, which is the graphical interface that you actually see when you're doing anything with AGS. But there is a service called Sentinel. If we click on that pane there, you can connect Server Studio to Sentinel services running on various machines if you wish, in which case you create additional connection details, and you can have a list of Sentinel services that you can see what's going on various machines in the one Server Studio session. On Windows, Sentinel does appear very much as a service, and you can stop and start it using Windows services. On Unix or Linux, it's a background job which you start and stop with a command line. There are three types of thing you can get the Sentinel service to do behind the scenes. You've got monitors, in which you can have it check the health of the database, record statistics. We've got SQL Capture, which is what I'm going to look at in this segment, and jobs would be equivalent to scheduled tasks in Windows or cron jobs in Linux or Unix. So you can just have it do stuff, whether it's SQL commands or operating system commands at specific times. But I want to look at SQL Capture in this segment. Other ways of capturing SQL statements which are going through the engine from whichever user would include iSpy for early version of Informix and OAT for version 11. But I would say that this is really a far easier interface to use than either of those. The idea is that you define a profile of SQL statements that you wish to record. Clearly, if you don't give it some conditions, you end up with a huge list of SQL statements being captured, so you can be quite targeted. So for this demonstration, I'm going to imagine that we have a problem with a couple of tables being excessively sequentially scanned. We believe there's a problem in that we need to define a couple of extra indexes so that the statements which do seem to be reading excessive numbers of rows from those tables would use an index and target straight in at just relevant rows. And let's imagine we don't know exactly what SQL statements are being run that are causing this, so we want to try and capture them as and when they happen, possibly leaving a SQL capture process running for a day or two, so that at the end we can look at the details of the SQL statements and then possibly to add an index. So under SQL Capture, you would go in and do new SQL Capture. To save time in the demo, I've got this prepared already, but I'm going to go through the edit wizard, which is exactly the same as if you were adding it in the first place. So this SQL Capture is going to be called sequential scans. You would just click on the database connection that it relates to, and this is where we define the guts of the SQL Capture profile. So I've said that we're going to run it every second. Now, when you're doing SQL Capture, it is really only a sample, because it's going to look for current SQL statements, how often you specify. So if a process ran a SQL statement and exited all in the gap between the time intervals that you're sampling, you might actually miss it. So you need to run this often enough that you're sure you're going to capture these statements, but not so often that it's going to put unnecessary load on the database engine. Now for the demo I'm going to run it every 1 second, and clearly we're on an offline test database. It doesn't matter about performance, and just to make sure that we pick up any statements we run, we're just going to run it every 1 second. On a production system I tend to do this about every 5 or 10 seconds. Okay, we can have the statements stored in the Sentinel repository. By default, Sentinel stores data in an embedded Derby database. We've got the option of storing it in an external Informix database, which clearly that's what most people do because it's much more usable. We'll see that for SQL Capture you don't actually have to store them in the repository, you can just run it on screen. I've got an example filter in here that I only want to capture statements by user Informix. You can have a session filter either by user, host or session ID, but not a combination. You can have multiple usernames in there. You would just add another username if you wish. Then over here I've said that I'm only interested in sequential scans on those two tables. I've gone in and given an object filter using this wizard, in which I just went customer and orders for the database that we wish. Then down here I've said, well, I want to only record statements that involve sequential scanning, so I've got sequential scans greater than 1, greater than or equal to 1. You can have that value can be more than 1 if you're sequentially scanning more than one table and then joining results in the one SQL statement. And I want to exclude trivial sequential scans. If you have a table that contains a couple of hundred rows, it's probably as quick to sequentially scan it than to use an index. So we're only bothered about ones where there's a significant estimated cost. On a production system I'd probably set that to 10,000 or 100,000. And you can specify what type of statement you're interested in. I want all of them. So that's how you define the SQL capture. So I have a test statement over a test script in this pane. I've got a deliberate missing joins in these statements just so that they do have quite a high estimated cost. It's a very small sample database. When I run those, we'd hope that it's going to record the first two statements but exclude the third, because we've not said that we're interested in recording statements involving the state table. So let's see if it works. So I'm going to start the SQL capture. Then in this pane I'm going to run the SQL. Back on the monitor, it's recorded 2 out of the 3 statements that we just put through. Let's rerun that. So we can see that it is recording each occurrence of that statement, not just the unique statement. So we've got the connection details, the time it happened. We can do a right click, edit SQL to bring up the whole statement that was executed. In fact, in the bottom of the screen you can see you can look at the SQL statement there, and you can cut and paste out of it, and it shows some details of the costs, etc. Moving across, you'll see that that's the database. The statistics held is the estimated cost, the estimated number of rows it's going to return, the number of sequential scans involved in the statement, any auto indexes and temporary files, temporary tables required to resolve the query. There's another tab there that gives you a summary, in that we've got repeated occurrences of the same statement. If I click on statistics, we get a unique list. So for each statement, it's going to show us the number of each and the average estimated cost. And we can sort by the average estimated cost descendingly, for example, so that we've got the worst ones at the top, and that is going to keep updated dynamically. Let's run that again, as and when more matching statements go through. So that's now 3. So clearly the point of all this would be that, given it's sequentially scanning, you need to fix it either by changing the SQL that's being run in the application, or possibly improving the database statistics. But of course the classic case is you've actually got a missing index. But to work out the details of why that statement is sequentially scanning, you can go directly into the execution plan there, without even needing to export the SQL into the SQL editor, which we've seen under the separate screencast on the graphical query analyzer. Then we can export the statistics or the full details of all the statements just with a right click, and we can export either just the sequels, or we can do all the data in the table. Again, normally you'd probably want to do it as a tab separated file, which will be openable in Excel very conveniently.